Hello everyone, am I audible?
Good evening, sir.
Yes,
Yes, you are audible.
Yeah. Good evening. So, in the last session of ours, we have discussed the week 11 topics. Okay, basically the have the partial derivatives. Okay, and Asian metrics and our Asian test to find the local minimum and local maximum, or whether it is a saddle point. Okay, and so today we are going to discuss uh, basically we are going to solve some questions on week 11. Okay, there are like four questions around. Okay, and these are all related to week 11 topics. Okay, so first we are going to discuss this. After that, if you have any doubt in any of the weeks till now, like from any week, you can ask your doubt, any conceptual doubt or any activity assignment, practice assignment questions. Okay, that you can ask after we solve these four questions. Okay, so this is the first question that we have for today. Okay, we have a matrix given to us that is in this form: a b b a, and a function f from R to R such that f of AB is equal to determinant of A. Then our first question is find the number of critical points of the function f AB. Okay, so first let's deal with this. So my function f here is defined as the determinant of A. A is given like this. So my function would be just the determinant. For determinant here is a square minus b square. So this is my function now. Okay. So we basically need to find the critical point for this function. So what we need to do for critical points? What is the process?
fx and fy has to be equal to 0.
Yeah. For any point is called to be critical point. Either the partial derivative, all the partial derivative at that point is 0, or the partial derivative at that point does not exist. Okay. So to find critical point, we first need to find the partial derivative. So here basically our variables are a and b. So let's take f a, it will be 2a, f b it would be negative 2b. Okay, so we can equate them to 0. So we have only one partial area, one critical point, that is just 0 comma 0. Okay, so at the point 0 comma 0, either it would be a local maximum or minimum, or it can be a saddle point. Okay, so number of critical points, there's only one. Okay, now which of the following is true? A is not a symmetric matrix. So what is a symmetric matrix?
The A is equal to transpose of it.
Yes, correct. If A is equal to A transpose, then it is a symmetric matrix. So this is my A. Its transpose would also be the same, right? Okay.
yes,
Transpose is just rows will become column, column will become rows. So as A transpose is same as A, so A is a symmetric matrix, but here it is telling not, so this option would be wrong. A square is a symmetric matrix. So for that we need to find A square. Okay. So it would be a square plus b square, ab plus ab 2ab, here also 2ab, and b square plus a square. Okay, and this is also a symmetric matrix, right? Okay, so a square is a symmetric matrix, and from here we can also conclude one thing, that if a is a symmetric matrix, x square is also a symmetric matrix, right? Now beta comma y is the critical point of my function f at the point a comma b. Then the matrix A satisfy A square equal to A. So the critical point that we got was 0, comma 0. So here my beta comma gamma is 0, comma 0. So if you just put them in the matrix A here, that is this, it would be just a 0 matrix, right? So it satisfies the criteria A square is equal to A. So 0 matrix, if you do the square of it, you will again get the same matrix. Okay. So this is also correct. Beta comma y is a critical point of the function. Then the matrix A satisfies that the rank of A is equal to 1. What would be the rank for this matrix? 0. Correct? Because all the rows are 0, so the rank of the matrix would be 0. Okay. I hope this question is clear to all of you. Okay.
Yeah, clear.
Yeah. Okay. So now let's move on to the second question. We have three positive integers, okay, which satisfy these following properties: that sum of a comma b comma c is 12, and the sum of square of a comma b comma and c is minimum among the sum of square of any such positive numbers which sum up to 12. Okay. So find the value of a minus 2b plus c. So how can we proceed with this question? Anybody would like to tell? We have given the two condition, and with respect to satisfying all these two condition, we need to find three numbers a, b and c. So how should we proceed with this?
Sir, a plus b plus c equal to 2.
12.
And then there is another one, a square plus b square plus c square.
Hmm.
And c can be expressed in terms of a and b, and substitute in that a square plus b square plus c square.
Correct.
And
Okay.
we will get a equation in two variables. Then find the fx. That is, I think we need to go up to Hessian matrix, right?
Yeah, correct. Yeah. So the way to solve these type of questions, we have given one expression here first. Our first condition is that the sum of these three numbers should be 12. Okay. Second is we want that the sum of squares of a, b and c, that is a square plus b square plus c square, okay, this has to be minimum among the sum of squares of any such positive numbers which sum up to 12. Okay. So from first of all these two condition should satisfy together, okay, simultaneously, that a plus b plus c has to be equal to 12, and their sum of their square should be minimum among any such numbers which sum up to 12, and there has to be first positive. Okay, remember this. So for that we can replace any of the variable with respect to the above condition. Let's I can write c in terms of a and b, that is this. Okay, so a square plus b square plus 12 minus a minus b squares. Okay, now I want my a, b and c. Okay, if I can find a, b, then from this equation I can also find c by putting the value of a and b. So basically I want my a, b to be like that, such that this value has to be minimum. Okay, so for that I need to first find the critical point for this function, and then we need to test whether that critical point is a local minimum maximum. Okay, so then find the local minimum point. Okay, so that value would be the minimum on that point a and b, this function give the minimum value. Okay, and that's what we want. So let's express this as a function of two variable, such that a square plus b square plus 144 4b plus 2ab. Okay, this is now my function. So if I want to find the partial derivative with respect to a first, then it will be 2a. Okay, so there are 2a squares. Let's first simplify it. So if you want to find the partial derivative with respect to a, it will be 4a minus 24 plus 2b. With respect to b, it would also be almost same, plus 2a. To find the critical point, we need to equate the partial derivative to be 0. Okay. Now, their RHS sign is same. Okay, 0 comma 0. So I can put 4a minus 24 plus 2b equal to 4b minus 24 plus 2a.
Is equal to 4.
Yep. Is equal to 0 actually. Okay. Their RHS side is same, so I have put their LHS side equal. Okay, this 24 will cancel out, and you will get 2a equal to 2b. Okay, 4a minus 2a and 4b minus 2b, which basically means a equal to b. Now you can put them in any one of the equation. Yes.
It will be 4.
There. Yes.
It's 4. A is equal to B is equal to 4.
Equal to 4.
Yeah.
You are saying.
A is equal
Right?
to 4. Yeah.
Acha, okay. You are saying the final value.
Yeah.
Yeah. That final value would be 4. Okay. So I'm putting a equal to b in the any one of the equation. 4a minus 24 plus 2b equal to 0. From here we got a equal to b. So 6b minus 24 equal to 0. B is equal to 4, and as b is also equal to a, so you got a and b to be 4. And from this equation here, we got 12 minus 4 minus 4. So c value also be to be 4. Okay. So a, b, and c has to be 4. Okay. Now in the question it is asking for a minus 2b plus c. So that is a minus 2b plus c equal to 4 minus 2 times 4 plus 4, that is 0. Okay. So that is our answer. Okay. One thing also we need to should check one before that is the point that we got 4 comma 4 here. Okay, that is the value of a and b. This point, whether it is a local minimum or not, using Hessian test, that we didn't do basically because that's only one critical point that we get. So it's most likely to be the local minimum. Okay. However, we should check this. But if you get more than 1 point, then we have to check through Hessian test whether it is a local minimum or maximum. Okay. So is this question clear to all of you?
Yes, sir. Second condition.
Yes, the sum of squares of a, b, and c. You can take any three numbers whose sum is 12. Okay, their sum of squares will be greater than these numbers 4, 4, 4. Okay. This is the minimum sum of squares of the numbers whose
ABC is minimum among the sum of square of any positive number which sum
not
up to
the
12.
ABC, not the ABC, the sum of squares of A, B, and C. This is minimum among the sum of squares of any positive numbers which sum up to 12. Okay, like you can also take like 7, 4, and 1. Okay, these three numbers also add up to 12, but their sum of squares would obviously greater than the 444, right? Okay, like that. So this pair, which sum up to 12, has the minimum sum of squares among the any pair which sum up to 12. Okay.
Okay, sir. Thank you.
So Pulkit, if we draw this, this equation in a chart, we will see the minimum value is attained when 444. Is that
Yeah.
how? Huh?
Yes, yes. Okay. Yeah. The minimum will occur at the point 4, 4. Now, any more question from this? Okay. Yeah. So this is the third question. Okay. It's the easiest one here. We have given just one function and we need to find the number of local maxima, minima, saddle point, and the point at which the Hessian test is inconclusive. Okay. Remember this one thing, none of the condition for Hessian test would be given in the exam. Okay. You have to remember all the conditions for Hessian test, like at what condition it is local maxima, at what condition it is local minima, all that for both 2 variable and 3 variable. Okay. None of this would be given in the exam. Okay. So just a function. So first find the critical point. So for that, partial derivative equated to 0. So fx is 6x square plus 6y square minus 150. Fy is 12xy minus 9y square. Okay. We have to equate them to 0. Now from this equation I can take y common. 12x minus 9y equal to 0, y equal to 0, or 12x equal to 9y. Okay, that is basically 4x equal to 3y, and let's put y equal to 4 by 3x. Okay. Now we have to put these two values in the above equation and find the value of x. So if we put y equal to 0 first, then we got 6x square minus 150 equal to 0. 6x square equal to 150, 6 to 25. Okay, you got two value, that is plus minus 5 on y equal to 4 by 3x. You got 6x square plus 6 times 16 by 9 x square minus 150 equal to 0. Okay, so there is 6x square plus 96x square by 9, 0, 54. 15,92250. Okay. Two two five zero. Root 50. Okay. This was correct, right? 16,696, 9,654. Wait. Should not be. It will be 135. 9,45, 950. Yeah. 150 x square equal to 1350. This got 9 times. X square equal to 9, x equal to plus minus 3. Okay. Now on putting x value here, y equal to 4 by 3x. So if x is equal to positive 3, we got y equal to 4. If x equal to negative 3, we got y equal to negative 4. Okay. Now we need to make the pairs of the critical point. Okay. On y equal to 0, we got two values of x, that is positive 5 and negative 5. Okay. On the value of x to be plus minus 3, we got y to be positive 4 and negative 4. Okay. So these four are the critical points. Okay. On solving the above two equation, we got these 4 points. So now to do Hessian test, we need to take the partial derivative of the partial derivatives. Okay. So on taking the partial derivative of fx with x is just 12x. On taking partial derivative of y with respect to y
Excuse me,
is,
sir.
yes,
Can you please tell which question you are solving?
and this is from one of the PYQ.
Okay, sir.
Okay. Yeah. So partial derivative of y with respect to y is 12x minus 18y. Okay. And because this is a polynomial function, so mixed order partial derivative would be same for this. Okay. So fxy or fyx would be same 12x. Okay. No, 12y. Taking partial derivative of y with respect to x, so it would be 12y. And here also it would be the same. Okay. So for Hessian matrix any point, my derivatives are 12x minus 18y and 12. Okay. Now, in a case for two variable, when any point is local maximum, what is the condition for local maximum? For any critical point.
Delta is greater than 0 and the f of xx is less than 0.
Less than 0 and determinant is
Greater than 0, sir.
okay. What about minimum?
Sir, f of xx is greater than 0 and determinant is greater than 0.
Correct. Now when it is a saddle point?
So determinant is less than 0.
Correct. And test is inconclusive. That
When
is
determinant is 0.
correct. This case is same for two variable and three variable. That is the test is would be inconclusive when my determinant becomes 0. Okay.
Okay,
So
sir.
see, in the question it is asking about all the four things, right? Number of maxima, minima, saddle point, and the point on which Hessian test is inconclusive. We always need to find the determinant. Okay. So the determinant of Hessian matrix, okay, would be 12x times 12x plus, sorry, plus, no, it is minus 18y minus 144y square. Okay, this is the determinant for my Hessian matrix. Okay. This was the determinant. Okay, and the four critical point that we got was this. Okay, and our fxx was this 12x. Okay, so all we need to do is just put this value in this equation and this equation and check. So first check for the determinant with respect to 5 comma 0. Okay, so this term would be 0. Okay, for these two this term would be 0, right? So you only care about this. And also, yes,
Is 0.
yes, so the determinant for these will be basically 144 x square. Okay,
Yes.
for these two options, and that is if x in both the case it doesn't matter, determinant would be the same and it would be positive, right? For these two options 5 0 and negative 5 comma 0,
Yes, sir.
because this term would be 0, determinant would be 144 x square and it is always positive, it doesn't matter. Okay, so determinant is positive, rest depend upon the term fxx. When x is equal to positive 5, this would be 60, and x is equal to negative 5, this would be negative 60. So 5 comma 0 will become my point of local minimum, negative 5 comma 0 will become my point of local maximum. Okay, now
Sir, how did you this conclude that x equal to minus 5 local maximum? That you got.
from here, okay, because we need to put value
Oh,
of
yes,
x
sir. Yes, sir. Okay.
as x. Okay, so when x equal to 5, this is positive, so local minimum. X equal to negative 5, this is negative, so local maximum.
Yes, sir.
Now remaining for these 2 points. Now we need to put the value here, there's no shortcut. So for the point at 3 comma 4, 12 3 is 36, 36 minus 18 4 is 72. Okay, negative 2 minus 72, and of course this would go in the negative, right? This is coming out to be negative. Okay, whatever it comes out. So if determinant is negative, it's the saddle point. Okay, now at the point negative 3 comma negative 4, okay, it would be negative 36, negative 36, positive 72, minus 144, 60. Okay, here it would be positive 72 and negative 144, 16. So we can take 72 common, and this would be 2 times 16. Okay, so this is also
How
negative.
it would be, sorry, 72, how it can? Actually, it should be 36 into 36, right?
Oh, sorry. Yeah, my bad. It would be 36 into 36, 36 square. Above
But
was,
negative, minus 36.
yeah, yeah. Here also we left with negative 36. So here also it was the same. Yeah. Okay, so it's still it is negative. Okay. Yeah. Still it would be negative. Okay. So it would be still be a saddle point. So we got one local maxima, one local minima, two saddle point, and there's no critical point at which Asian test is inconclusive. Okay. So any doubt in this question?
Sir, in these type question, I have one doubt. Sir, it is always for the point of exam, x, y, y and x, y and fx, yx is equal. Other than the diagonal function, other than the diagonal element.
Sorry,
Sir, in
like yeah,
Gaussian
you are
matrix,
telling that
other than the
basically
diagonal
mixed
matrix.
partial derivative you are taking,
Yeah.
mixed partial. So mostly we will be dealing with those type of functions in our course where mixed partial derivatives are equal. Okay, in exam mostly if you will see either mostly time the polynomial function for those mixed partial derivatives are equal. Okay, unless it may happen like you may given one function and in that it is asking for you to find whether the mixed partial derivatives are equal or not. Okay, like you have given the function uh, you have given the what we say piecewise function. Okay, in that it may happen that the mixed partial derivatives are not equal. Okay, but mostly we will be dealing with the functions in which we have partial mixed partial derivatives are equal, especially if it is asking you to find the Hessian local maximum minima using Hessian test, because in Hessian test we always assume that the mixed partial derivatives are exist and they are equal. Okay.
Okay, sir. Thank you. And sir, second point is that we find the critical points many times. Then the combination is the final answer, or many times it may be less than or more than whatever we find the value of x, y. Like we find the value of x 2 and the value of 4y is 2. Then the final combination critical point must be 4. Taking one
uh,
from the x and taking
basically if you see
many
it
times it's
basically depends.
less than or more than I seen one question from activity, I think, or somewhere.
Yeah, see, it is not basically depends. It all depends upon the equations. Okay, what equations do you have? Okay, so you basically need to consider that if you take any value of y, okay, do you need any value of x for that equation to be zero? Okay, just like in this equation. Okay, on putting y equal to 0, the equation becoming 0. Okay, so but if you see these two equations, okay, these two equations have to satisfy simultaneously. Okay, so that means whatever the value of y here you will put, you will also have to put the value of y in the above equation. Okay, so if we are putting y equal to 0 here, we have to put y equal to 0 in this equation and also find the value of x. On what value of x when y is 0, this equation is satisfying. Okay, now sometime it may happen that both of the equations are not related to each other, just like if this equations is only for let's say now my fx here comes out to be 6x square minus 150 equal to 0, and fy it was 12xy minus 9y square equal to 0. Okay, first equation is only about x. Okay, it does not contain any y. So if you solve the first equation, 6x square equal to 150, okay, you will get x equal to positive negative 5. Now on solving y second equation here, okay, you will get one y equal to 0 and again this value, okay, y equal to 4 by 3x, and this x value here you need to take from the above equation. Okay, so you'll get 4 by 3 into 5, okay, that is 20 by 3 or negative 20 by 3. So here the combinations that will make is, see, on the first equation when x is positive 5 or negative 5, okay, from here this first equation is totally depends upon the x. Okay, it does not depends on y.
Sir,
Why?
sorry interrupt you. Sir, excuse me. Sir,
Yeah.
Your mic is not on.
Please, I have one doubt. Can I ask?
Yes.
Yeah. So, what level of complex equations will be given on these problems? Like relate to?
Not more than these. Okay, this you can consider the standard. Okay, this will be the last standard equation that you can consider. Okay. At
Now
most
that
here, you like the highest solution that I have seen so far is we got 9 critical points. Okay, that was when the power was 3. So that was the like highest times. Okay, not more than that you will get.
okay.
Okay.
And with respect to the complexity in creating in coming up with the derivative, will that be like lands and e powers, or will it be all in the x squares, y squares? What do you think?
Yeah, that may happen. Yeah, for taking like derivatives and all that, you might get a log function. You might get trigonometry functions. Okay, you might get all of these. Okay.
Okay.
Yeah, sir.
Yes.
Sir,
Yeah.
from here, the critical value is 6. 2 value from x and 3 value y. If you combine all of them, then finally I got the 6 critical value.
No, it's
That's
not
the my
necessary.
confusion. That's the my
It's not.
confusion.
See, always you know need not to be make pairs. Okay. Let's see. Yeah. Here. Yeah. See, in this questions. Okay. No, this one be too simple. This one is the linear solution. Okay, let's consider this one. See, it depends upon see. Okay, you can make the pair. That's fine, but that pair always need not to satisfy the condition. Okay, you need to check that the pair you are getting, okay, is satisfying both the equations or not. Okay, that you need to check always, that the point that you are getting is should satisfy both the equation. If both equation are not correlated to each other, that if I remove x from here also, okay, then you will get two values of x, okay, and two values of y, right? 12y minus 9y square. So you'll get two values of x and two values of y. Okay, then you need to make pair because both the equations are not correlated to each other. Okay, but if both the equations are related to each other, like here that we got, okay, then if you got one value of y here like that, then you need to put that value of y and got the solution. Okay, now if we got only one value of x from here, from both of them, okay, only one value you are getting, then you will get only those points as the value. Then it will be just you can say 3 critical point, right? Let's say if you are getting only 1 as your value of x on putting y equal to 0, and also when you put y equal to 4 by 3x, then there will be only 3 critical point, 0 comma 1, okay, sorry, only 2, okay, 1 comma 0 and 4 by 3 comma sorry, 1 comma 0 and 1 comma 4 by 3, okay,
Yeah, sir.
on putting, okay, so that's what you need to do. If both the equation are related, like both have x and y, if both have x and y terms, okay, then you need to consider like on taking from here, like solving equation, I got this value of y, then this value of y should also satisfy in this equation, right? Because both the equation should satisfy, that should be equal to 0 simultaneously, okay. So based on the equation you may get, it's not
Okay.
like
So
making a
first,
combination.
okay, sir. So first, sir, if we procedure is that find the critical point, and then the critical point must be satisfied the equation fx and
Yeah, that is,
fxy
yeah, fx should be also be 0 and fy should also be 0.
on
Only
this
those
point.
point are, yeah,
Okay.
both should be 0, okay,
Yeah.
on that critical point.
And on which these equation not satisfy, not equal to 0, that is not the critical point. Okay.
Not the critical point, okay.
Okay. Okay.
Yes, critical point is the point on which either like partial derivative with respect to each variable is 0 or the partial derivative does not exist. Those points only we consider the critical point. Okay. So if you are taking the first case, that is partial derivative with respect to each variable is 0, then it should be happen with each variable on putting that point values. Okay.
Okay, sir. Okay, thank you.
Yeah. So this is the last question for today. Find the minimum value of the surface area of a rectangular box that has a volume of 1000 unit cube. Okay. So how should we proceed with this question?
The surface area formula we need to use.
What is the
2 into
formula for? Yes.
2 into AB plus BC plus CA.
Okay. And what is the volume formula for rectangular box?
ABC.
Yeah. Okay. Now, what we want to minimize this value, that is this value, and we have given our volume to be 1000. Okay. So same like as the question number 2, where we have given the sum of three numbers to be a plus b plus c equal to 12. Here we have given the product of the numbers. Okay, 1000. And in the question 2, it was telling that the sum of their square has to be minimum. Here this expression has to be minimum. Okay, same conditions. Okay, so you can find c equal to 1000 by ab and put it in the above equation. 2 times ab plus 1000 ab plus 1000 ab times a, that is 2 times ab plus 1000 times a plus 1000 times b. Okay, so I can define my function of a comma b as 2ab 2000 by a plus 2000 by b. Okay, if I'm going to take my partial derivative with respect to a, what it would be?
2b
Hmm?
minus
Correct. Minus
2000 by a square.
correct. And same adjust it would be here 2a and here b square. Okay, now we need to equate them to 0. Okay, so again we can consider that their RHS side is same, so I can just consider this case. Okay, so it would be b. If I take 2 common from both of the side and cancel it, I will left with this. Okay, on manipulation we got b minus a square minus square okay. It would be not a good idea to take this. Okay, 1000 b square. If we take the 1000 common, and b square minus a square upon a square b square a. So 1000 b plus a. No, from here we're not going to get any solution, right? A square b square. So Let's simplify the equation from here then. 2a square b minus 2000 by a square is equal to 0, and 2a square b minus 2000 is equal to 0. Then here it would be 2ab square minus 2000 is equal to 0. I guess now we can put them equally. Now let's take their RHS side as same. 1000 equal to 2ab square minus 2000. Okay, this will cancel out. So
Two will be
this will cancel this. This will cancel this. So we got 2a equal to 2b. That is a equal to b.
Yes.
Now put it in any one of the equation. So let's put here, okay, in the simplified version. So we got 2a cube minus 2000 equal to
10.
0. It is a cube equal to 10,000, a equal to 10. So
Yes.
b would also become 10,
Yes.
and my c was 10,000, oh sorry, 1000 by ab. So that is also 10. Okay,
It's a cube.
so yeah. So we want the minimum value of surface area. So just put ABC equal to 10 here. That would be just 2 times 100 plus 100 plus 100, 3 to the 600. Okay, that should be the minimum value of surface area. Okay, and usually the minimum value occurs when all the three sides of my shape is equal. Okay, that is when it's a cube, then it will have the minimum surface value of the area. Okay, any doubt in this question?
Pulkit, don't take me wrong. If there is any other shape given, will they supply the surface area formula as well?
Okay, I'm not sure. They might give. Okay, they might give this as a hint, or usually it will be given in the expression like the minimum value of surface area of let's say cone. That is whatever it's given. Okay, so it might, they might give. Okay, but
Okay.
it's not sure.
Sir,
Usually, yeah.
sir,
Yes.
can you summarize the answer you have done?
Okay, okay. Usually we only take the rectangular box case. Okay, that case we generally do. Okay. Yeah. So to summarize this question, okay, in the question it is asking for the minimum value of surface area of rectangular box that has a volume of 1000 unit cube. Okay, so the volume that is the for rectangular box, that is the cuboid. Okay, that is ABC, right? The multiple of all the three sides. That is, you can say length into breadth into height. Okay, that is my volume formula. That is given as 1000, and we are asking to find the total surface area. Okay, of the box, that is given as 2 times of length time breadth plus breadth time height plus height time length. Okay, so it is given that ABC we are considering as the length, breadth, and height of the my box. Okay, so ABC is given as 1000, and with respect to this condition, we want to minimize this. Okay, so first we are just applying that I can convert any one of my variable from here with respect to this condition. Okay, because both the
Sir, if
condition has.
I
Hmm.
okay, sir, if I take A is equal to 1000 by
BC.
AB,
Yeah.
BC, yeah,
No, BC.
then is then
You will
the
get the same
answer becomes okay. Okay, sir.
You will get the same answer. Okay, you can take any variable, you will get the same answer. Okay,
Okay, sir.
so I just replace C variable from here with 1000 by AB. So this would be my simplified form. Okay, moreover, this would be my simplified form of my function. I want this function to have the minimum value. For that, we found the critical points f and ab. More simplifying them, I got this my fa, that is 2a square b minus 2000 equal to 0. fb 2ab square minus 2000 equal to 0. As their RHS side are equal, I just put LHS side to be equal. So on simplifying, we got a equal to b. On putting in any one of the equation, let's consider this. Okay, then we got 2a cube minus 2000 equal to 0 because a is equal to b. So it would become a cube here. So on we can cancel 2. Okay, 2 will take common and we cancel out. So we got a cube equal to 1000. That is a equal to 10, and a is equal to b. So b is also 10. C is nothing but 1000 by AB. So C will also become 10. Okay. And it is asking the minimum value of surface area. Okay. So that would be just this. Okay. 2 times 100 plus 100 plus 100 is 600. Okay.
Okay, sir. I got it, sir.
Yeah. Yeah. And actually for this question, the formula was given in the question. The value like the surface area formula and volume formula was given. I just removed it. Okay. So it may
Okay,
happen
sir.
like the formula may be given to you, or they directly give it in the expression. Okay, like this value, we need to find the minimum value of this when this is given to you. Okay, so most probably the formula will be given for that. Okay, but for generally that you can remember the formula for cube and cuboid. Okay, for that you can remember. Okay. Yes. So this is all from my side for today. In the week 11, mostly these type of questions are asked. Okay, that one type is this. Okay, one condition for the variables is given to you. Okay, and with respect to that condition, we need to minimize one function of that. Okay, that is the one type of questions. One would be just simple these type of questions. Okay, that is one function is given to you and you need to find the local maxima minima saddle point like that, or the Hessian matrix. Okay, Hessian matrix at that point, or this is just another way of asking. Okay, yeah, these are the most general type of questions that are being made on the week 11 topics. Okay, differentiability, that is the last topic for week 11. Okay, so as we discussed in the last session, that usually on the differentiability question does not ask. Okay, because the main point for the differentiability was to just remember that if a function is differentiable at the point a, then it tangent line exists and linear approximation exists. Okay, so that is all for week 11. Now if you have any doubt from any week, that you can ask.
Sir,
Yeah.
sir, can you open the week 9 Lavanya ma'am class PDF? I have a doubt in the gradient calculation.
Yes. I will take you out after this doubt. Okay. Okay. Week 9, right?
Sir, it is in the master folder, sir. Live session notes, week 9.
Okay, which PDF? First or second?
I think first, sir.
Yes.
Sir, can you go to the page number 14?
Okay. Hmm. Yes. This
Sir,
page.
this one, Lavanya ma'am has solved this using the limit formula. When I tried to solve it with the direct directional derivative formula, it is coming root 3 by 2.
Gradient. With gradient, you try to solve, right?
Cos 60 comma sin 60.
No, you tried using the gradient, right?
Yes, sir. Yes, sir.
Yeah, okay. Well, with gradient, it should work. Okay. The rate of change of function is sin xy at 1 comma 0 in the direction of 60 degree from x-axis. Okay. Okay. So unit vector is this. So my function was sin of xy, right?
Yes, sir.
Hmm.
At the
And-
point 1 comma 0.
And unit was cos 60 comma sin 60.
Sin
Okay.
60.
That is 1 by 2 comma root 3 by 2, right? 60 degree from x-axis. Okay. Yeah. Okay. So it should work the gradient method. Let's take the partial derivative with respect to x. Cos xy times y, right? Fy would be cos xy times x. On which point we need to find 1 comma 0. Okay. So it would be cos 0, that is 1, and y value is also 0, and here it would be 1, right?
0, right?
So gradient of x,
Y will be 0.
it would be fy. Fy would be 1, no? Cos is 0 and x
Yes, sir.
is 1. So we got gradient to be 0 comma 1. Okay. So gradient of f dot unit vector, that is 0 comma 1 times 1 by 2 comma root 3 by 2. So we got root 3 by 2. And what ma'am got? Root 3 by 4. Okay. Okay, 1 plus h by root, okay, minus f of 1 comma 0. So here sine of 1 plus h by 2 times root 3h by 2, okay. So plus 3h square. So wait a second. Here it
Yes,
is 1
sir. So here the 2 has not been
missing.
cancelled, I think.
Yeah.
The second term that was not cancelled.
Here it's, I guess,
Okay, sir.
ma'am has
Yeah.
mistake. It's okay.
Yes, yes.
Yeah.
Got it. Thank you, sir. Thank you.
Otherwise, as the function is continuous, so you can surely find it using gradient. Yeah. Any other doubt? Okay, so yes, Malaya, what's your doubt?
Sir, what is the answer? Root 3 by 2 or root 3 by 4?
Root 3 by 2 would be the answer. Okay.
Okay, sir.
Hello, sir. Sir,
Yes.
can you open this practice assignment 9, question number 3?
Okay.
Practice assignment. It's about the graph
9.
of the functions. Yeah.
Okay, so practice assignment 9.
Question 3, the plots are there. With respect to equations, we have to find out which equation matches the plot.
Okay. Yeah. Yeah, so what's your doubt here?
Sir, how can I easily
Okay.
identify that And this will be that plot. Like I may have in terms of cube also, right? Say x cube, y cube in that manner also.
Yeah. Okay. So we have the function given, that is first x plus y and xy x square y square, and this is the exponential function. Okay. So now see, first function x plus y. What type of function is this? This is a linear
It's a
function, right?
plane. Yeah, linear.
This is a linear function. So see, the option 3 from here, right? This basically represents the
Yeah.
same, right? It is a linear
That
plane
plane.
equation.
Yeah,
Okay.
that I
So
understand.
that is clear. Okay. So one would be now for second.
Yeah, that is x into y. So it will be
X into y.
parabolic kind of thing. Like the value of x can be positive, negative. Similarly, y also can be positive, negative, right? So it can go below the horizontal plane also, right?
Yeah. And see, the option second, it is not going to the negative, right? It is not going to the negative in the graph. Okay. In the graph, option 2 and
Yeah,
option 1,
yeah,
okay,
yeah.
both of these two are the positive function always, right? These are the
Yes,
always
yes,
positive function. Okay. So
yes,
of
yes.
course, that's why the second option, for the second function, these two
First and
cannot
fourth
be our
one.
answer. So only the option 4 would be the answer, in which some part it is negative, some part it is positive. Now
Okay,
for
okay.
third, similarly, it is always positive.
Positive,
Okay.
yeah.
Yeah.
But
And
suppose in this case, say the first figure and the second figure both are above, say, horizontal plane, right? Positive that will be. But what about the shapes are here?
okay, for the shape.
Like maybe
Okay,
there
for
are
x.
four parabolas are there, right?
Okay.
It is an
Okay.
exponential function, right? So
Exponential
this
function,
fourth
right?
option is
So
Yes.
yeah, fourth option is exponential function. Okay. So see, first, if you see the first option, it is like the, if you consider in the case of two variable, it is giving you the parabolic form. Okay. While what happens in the exponential function, okay, at the point 0 comma 0, it does not encounter 0, right? For
Yes.
exponential function.
Yes.
Okay, it approaches to 0, but it never goes to 0, right? It only remains at the 1.
Okay.
Okay, right? If you put f of 0 comma 0, what would be the value?
X comma. Oh, what you're saying, sir?
If you put in the fourth function both is 0, x comma
Will be one.
x and y 1, right? It cannot
one.
go below. Okay, so from that you can identify this. Okay, so the second function is basically the behavior for the exponential function. Okay, like for it, in the case for two variable, right, we have studied this, something like this. Okay, okay, right,
Yes.
something like this when we have this one, I don't remember clearly. Okay, there are like two conditions. Which one was it? Hmm. Okay, no. I guess
Like
this was
it
for low.
ever be
Hmm? Yeah. This was, I guess, yeah. Okay. This was the condition for the logarithm. Oh, sorry, not the logarithm. Exponential, right? For the case for two variable. Okay. I mean for a single variable. Okay. So something similar you can like, it will be in the multivariable here also. Okay. So it just by some guesswork and like that, you need to identify this. Okay.
Here, this value will never be 0, right? We'll never have this 0,
Yeah.
right? For the last,
Yeah.
5 to the
Hmm.
power. Now, suppose, sir, suppose there is x cube, y cube. Suppose the function is x cube into y cube. So, in that case,
Yeah.
again, on both the sides above the horizontal plane, we'll have all those parabolic plots, right?
Hmm.
Or say in the first figure, sir, actually, how many parabolas are there? 4 are there above this one.
Yeah.
I mean, how can we say that, sir? I mean, what is the shape of this?
See, this is just for just for the understanding for the functions. Like it is for you can to have the imagination how the function graph may look like. Okay, this is for that only.
Yes,
So
sir.
as
By
a
looking at the plot, I understand that like at the ends or the sides are like they're bending to form the parabolic shape, right? So 4
hmm,
parabolas are formed by the sides of that surface, right?
yeah, see, this whole surface is going to the upward. Okay.
Yes, that is okay. But I'm
Yeah.
asking
Okay.
about those curves, sir. I find like four sides are there for the plane, and they're bending. Each side is bending to a particular parabola. So 4 parabolas are corresponding to 4 sides of the plane, which is the bending surface. Is it like that, sir?
Okay, let's see it in GeoGebra. Okay.
Okay.
X square y square. Okay. Okay. Yeah. Is my screen visible? GeoGebra screen.
Yes, sir.
Yeah. Okay. So this is like how the function will look. Okay. For x square y square. For each point in the function, okay, it will be only the upward condition. Okay. So that's how it is going. Okay.
Like, sir, how can I identify that? With respect to that particular expression x square y square, so we'll have 4 all those parabolas. If you see the on the top view, sir,
Hmm.
on the horizontal planes we'll have all these 4 parabolas.
Yeah, kind of like that we have. Okay. So each consider you can say these are like kind of parabola. Okay, because each will go to upward. Like see, if you
So suppose here if I consider z to be 0, the thickness to be 0, then on the plane like they will be parabolas only, right? So initially that is a plane. Okay, it has 4 sides. Say suppose rectangular or say square size. Then the sides are say they are having the banding shape of the sides of that particular
hmm,
plane. Is it like that?
yeah, yes, okay. See this you can now let's see for a one particular point if we fix this is here your parabolic side, right? Okay. Now for any fixed point you can see this is like parabolic behavior for the function. Okay. For each side here this is what happening in the function. Okay. So basically that's what happening in my function for this case. Okay. When x square and
Yeah.
y square it is happening all the values will be in the positive domain. Okay.
Yeah. And if it is suppose x cube into y cube, then the maybe the shape will be same, and one that same part will be also on the other side of the horizontal plane, right? Because
Yeah. See,
uh,
half part would be the positive side, and some part would be also in the
yeah.
negative side, right?
Okay. If
Okay.
one is square and another is cube, right? But if both are cube, then I mean the similar symmetrical part will be also there on the other side.
Now let's do it cube. Okay. Before there was one more part, like, see, now half, only these two parts are there, and they are on which we have the negative points either on x and y. These parts are going in the negative domain. Okay.
Yes.
Okay. Yeah. As
Yes.
either both we have as the negative or both we have as the positive. Only those parts would be in the positive side. And either if
Yes.
one of the positive and one of negative, then we have the negative
Yes.
side.
Yes.
Okay.
Yeah. Understood. Yeah. Thank you, sir.
Any other question?
No, sir. I don't have.
Yeah. Okay. Then next we have Manish. What's your doubt?
The graded 11 last question.
Okay. Graded 11 last question.
Sir, will there be any mock test for the end term?
Yes. Yeah. Yes. It may be released by tonight or by today. It will be or by tomorrow. Sorry. Okay. It will be released. Okay. Not for end term.
Okay. Sir, your next sessions will be previous year questions, right?
Yeah. Yes.
You will be going by the full question paper, or you'll be going by the week's content of the week?
No, by the full question paper. Okay.
Yes.
And we will discuss some concept on that if we like. On the questions, we can discuss the concept also.
Okay. Sir.
A company produced two types of chocolate, one that sell for 3 rupees and another at 2 rupees. Total revenue in lakhs from the sale of X lakh chocolate at 2 rupees and Y for 3 rupees is given by the function f, and total cost is given by the function g. Enter the maximum profit. Okay. So see, f function is the total revenue. Okay. That means you can say this is my selling price. Okay. And g function is my cost price. So profit is what? Selling price minus cost price. That is f minus g. Okay. So do the f minus g, and it is asking for the maximum profit. So you have to basically find the local maximum for the function f minus g. Okay.
Okay, sir, got it.
And whatever the point comes out, just put them in the equation and got the maximum value. Okay. Okay. So any other doubt do you have?
No, sir.
Yeah. Kshitiz, what's your doubt?
Sir, question number 5 of 10.2.
10.2. Question number 5.
5.
Okay.
Please, sir,
Okay. Which
how
of the
to find
follow?
unit vector along the line they have given?
See, the unit vector would be in the same direction, right? Oh, sorry. The unit vector has to be in the same direction in which the line that is given to us. In the question, it is asking that which of the following is the tangent line passing through the point 1 comma minus 1 and parallel to the line this x of t equal to t, y of t equal to 1 plus 2t, z of t equal to negative 3 by root 5 t. So whatever the direction of this line, x equal to t, y equal to t, z equal to t, that is given to us, whatever the direction of this line would be, the line which would be parallel to this line will also have the same direction, right?
Yes, sir.
Okay. Now you need to compare uh, the equation of this line to the whatever we have parametric equation. Okay. So we have given x of t equal to t and 1 plus 2t, y of t is equal to 1 plus 2t, z of t is equal to negative 3 by root 5t, right? Now if you compare this the parametric equation, okay, parametric equation is x of t equal to a plus t u1, y of t equal to b plus t u2, okay, z of t equal to f at the point a comma b plus t f u at a comma b, right? Okay, so
Yes, sir.
where what is this u1 u2? These are the unit vector, right? So
Yes, sir.
what will be the u1 value here?
1.
1. u2 value here 2.
2.
Okay, so that would be my
Understood.
unit vector.
Understood. Thank you, sir.
Now next, any more doubts, Kshitiz?
No, sir. Thank you.
Okay, Kaustav, what's your doubt?
Yeah, sir. Activity question 10.2, question number 1.
10.2. Okay, same question 1.
Yeah.
Okay, x square sine of 1 by x plus y, x square sine of 1 by x plus y when x is not equal to 0. Okay, and 0 is x is equal to 0, and 0 when x is equal to 0. What we need to identify here is fy is continuous at the origin and fx is continuous at the origin. Okay, so see, remember this, that whenever we have piecewise function like this here, okay, like here function has two definition, right? At the origin the function is two definition, correct?
Yes, sir.
So whenever we have piecewise function, we always need, if we are finding the here partial derivative at the point 0 comma 0 where function is two definition, okay, so because of that always use the definition of the partial derivative, okay, to find the partial derivative. Now if it is asking for you to find the partial derivative at the point 1 comma 0, then you can use your method like taking y as a constant to find the partial derivative with respect to x and treating x as a constant to find the partial derivative with respect to y. But at the point 0 comma 0 the function is two definition, or you can consider at any point 0 comma y where x value is 0 the function is two definition, okay. So along this any point if it is asking for the partial derivative, we have to always use my definition of function, that is limit h tends to 0 f of a comma b plus h times 1 comma 0, okay, minus f of a comma b by h. This would be your fx and fi would be just 0 comma 1, okay. So if we want to find fx here, it would be limit h tending to 0. We are finding the point at the 0 comma 0, h times 1 comma 0 minus f of 0 comma 0 by h, it is f of h comma 0. At 0 comma 0 function value is 0. Now f of h comma 0, it would be h square sine of 1 by h, okay, plus 0, so it would be just this by h, limit h tending to 0, okay. Now if you cancel this we got limit h tending to 0 for h of sine 1 by h. Okay. Now, what would be the limit for this? Can we find?
Yes, sir. One, I
It's
think.
one.
Because, yeah.
Okay. Now, for fy,
Sine
if you
theta
check,
by theta, then only one it will be.
yeah, okay. For fy, if you check, limit h tending to 0, f of 0 comma h, okay, by h, f of 0 comma h, it would be 0, right? Because at this point it is 0, so 0 by h, 0. Okay. Now what it is asking in the question then, fy and fx is continuous at the point origin. Okay, so we got fy and fx to be 1 and fy to be 0. Okay, so fx equal to 1 if you are approaching at 0 comma 0. Find the number of characteristics. Both should be correct. What's the answer? Okay, 0. fy is continuous at the point origin. Okay. Okay, x squared sine of 1 by x plus y. Okay. No.
So we may need to find the full expression, right? Fx in terms of
Okay,
xy.
just see. Our function was f of x comma y, x squared sine of 1 by x plus y, when x is not equal to 0 and 0 and x is equal to 0. Okay, so what you are saying? Okay. Yeah, so okay. So this got it. We are checking for the origin. We need to also consider the case for the when function is not at the origin. Okay. So this is the function fx when x is equal to 0. Okay. So if x is not equal to 0, in that case, what would be the partial derivative?
1.
No, when x is not equal to 0, then
Okay. Then we can use the just normal partial derivative, right?
Yeah. Okay, then x square to x. This one we got when x is equal to 0. X square sine of 1 by x. When x is not equal to 0, 2x sine of 1 by x plus x square cos of 1 by x. This is when we are not at the point origin, right?
Mm-hmm.
And when we are at the origin, this, that is, and this. Okay, so we basically need to check now this function is continuous or not. Okay, so okay, if we are approaching for this function, it is in only one direction, so limit for the function if we approach from negative 2x sin x what would be the limit for this function? Okay, cos sine 1 by x square cos 1 by x. This exists at 0, 0 limit exists, right?
It will approach to 2, right, sir? When you apply the limit, it would be 2.
Oh yes. The limit would be here 2. Yeah. Okay, so it not be continuous. Limit exists, but it not continuous. Yeah. And my function value is 1. Okay. So the limit exists, but it is not continuous. Okay. As this will go to 1, this will go to 1. So the limit exists. Oh, sorry, this will go to 0, right? While this will go to 1, so the limit would be 0, but my function value is 1. Okay. At 0, my function value is 1, while the limit is 2. Okay, so it is not continuous. Okay, we got for fx, then fy also, I guess, same procedure. When y is 0, we got it as 0. Okay, not for the y case, when x was 0. Okay, here also, because for the x condition it is changing. When x is not equal to 0, we got it as a 1, right? Again, the function is also not continuous. Okay, at 0, the function, the value of the function is 0. Okay, while we are approaching, it is 1. Okay, so both fx and fy are not continuous. Okay, so I will just repeat it once again. Okay, so the function given to us was x square sine of 1 by x plus y. Okay, when x is not equal to 0, and 0 when x is equal to 0. So we found the fx and fy that was at the point 0, 0. But as we need to find the partial derivative, they are continuous or not. So we also need to check what is the partial derivative around that point. That is when they are not at the origin. Okay. So when they are not origin, that means x is not equal to 0. So when x was 0, we already found. When x was not equal to 0, we found this. Okay. So the limit of the function at that point was 2, while my function value was 1. So my function is not continuous. Okay. Same for the y case. When x was 0, we found my partial derivative to be 0. When x was not 0, we found it to be 1. And this function is also not continuous. So both fx and fy at the point 0, 0 is not continuous. Get it?
Yes, sir. Yes, sir.
Any other doubt?
Sir, one doubt is, sir, can we use the Hospital's rule for multivariable functions?
See, L'Hopital's rule is only for single variable. Okay. Hello?
Yes. Hello, sir.
Yeah. L'Hopital's rule is only for single variable.
Okay.
Okay. Yes, so now, anybody has any other doubt?
Sir, what about this module 12, sir? Week 12?
Week 12 is the dummy week for maths. Okay.
Okay. So we'll not be
It's the same.
discussing.
It's the same as week 11. Okay. Yeah. Week 11 and week 12 are same. Okay. So just the dummy week. Okay. Anyone, any other doubt? So tomorrow, I guess from tomorrow, the revision sessions are starting, right? For maths 2. Okay, what's the schedule? Okay, yes. So from tomorrow onwards, the revision session by instructor for maths 2 is starting. Okay. On 17, 19 and 21, we have maths 2 revision session. Week 1 to 4, 4 to 8 and 9 to 11. And on 18, 20 and 22, we have PYQ sessions. Okay. In that, if some time left, we will also discuss the mock. Okay. Mock for NTEM. And in that, anytime you can ask your doubt from any other weeks if you have. Okay. And mock will be released by tomorrow, I guess. Yeah. Okay. So from now on till 22, we have everyday sessions. Either one day it will be instructor, and other day it will be a TA session. Okay.
So all will be recorded, right? It would be
Yeah.
streamed. Your
Yeah,
your
it will be
TA sessions
streamed.
also.
Yeah. Mostly it will be streamed. If it not, then it will be recorded and then later it will be put on YouTube. Okay. And the last two
Oh.
TA sessions, like for week 10, yes, Satya.
So, just curious, I mean, just out of curiosity, how do you manage? I mean, you have your own courses, right?
Yes. Well,
Maybe it will be tip for us. So, how do you manage?
well, it's not. I feel like for maths too, it's not that much work. See, there's only like 2 sessions per week. Okay, and that is like 4 hours. And other than there are like some extra other work. So if you give your 100%, then yeah, it's manageable, obviously. Okay. And
Okay.
besides, it's my like second time for being a TA. Okay, so like I'm used to it now. Okay.
Yeah. And how many courses are you appearing this term?
I have 3 courses.
Okay.
So it's not like you cannot manage, you can manage it easily.
Got it, sir.
You are doing a degree in IITM, right? So other than this,
No. I am see all that TAs have to be in person present at the IITM. Okay, so that's the reason we are here. I am doing this degree standalone currently. Okay.
oh, okay. Okay.
Hmm. If you want, you can also become TA from next term.
Sir,
Hmm?
sir, I think week 11 session 2 note was not uploaded in the portal.
Week 11.
Yeah, session 2 note.
See, week. No, there was only, I guess, 3 sessions. One was on week 10, one was on week 10 and
Actually,
11.
sir, of Lavanya ma'am.
Okay. You are saying that it is not there in YouTube.
No, it is not in the masters folder.
Okay. Okay.
She
PDF.
did combinedly in
Yeah,
week 10
combined.
and 11. She combined,
11.
and then one more week she did alone for 11. So
Yeah.
9, sorry, 10 and
11 is combined, and 11 is one more there. Okay. And one session that was on 14th, it got cancelled. Okay. And now I guess the week 10 TA sessions are also there. Yeah. Okay. So the 2 sessions before that we took for week 10, okay, they have been uploaded now. Okay. Week 10 session 1 and the one which we solve some practice questions. Okay. Both have been uploaded. You can see them.
Sir, can you share the that link of discourse where you put all these materials? Can you please share it in the
Okay.
chat box?
Okay. Mm. Yes. Okay.
Yeah, thank you.
No, for TA ship you need not to be in diploma level. Okay. Uh, it's just that there are like first condition that you should be active in this degree for at least 2 terms. That means if you want to become a TA in January 24 term, then you should be active in the degree for like September 23 and May 23 term. That means you did not have taken any RK between these 2 terms. Okay. If you have not, then you will get a email regarding that, basically the form for TA ship that you can fill, and that they will ask you like your personal details like phone number, emails, and etc., and the course for which you want to be TA, and the uh, statement of purpose SOP for your TA. What's your motivation for the TA? Okay. And then they will like filter the candidates based on your CGPA, your grade in the course for which you are applying to be TA. Okay. And your, you can say, number of courses, current term load in the degree. Okay. Current term CGPA, etc. And after that, if you are in the filtered candidates, then you will get a mail from the course team regarding the interview. They will like ask you for the slot for which you want to give the on which timing you will prefer for the interview, and they will ask you like the concept on which you have your hard grasp. Okay, like in maths 2 we have only two concepts, that is linear algebra and multivariable calculus. In stats 2 we have three, I guess. Okay, like continuous random variable, discrete random variable, and hypothesis testing. For maths 1 there are like sets and relation, function, calculus in one variable, and graph like that. Okay, so if you want maths 2, then there are like only two concepts. So just select one of them and the time slot. They will take interview at your time slot. If you are selected, then you will get a mail after 2-3 days that we found you suitable. If not, then they will reject. Okay. Required CGPA is 8. Okay. 8 is the required amount of CGPA they will prefer, and you have at least A and or F in the course grade. Okay.
Sir, they send this TSC form to everyone or the selected candidate, because I didn't receive any TSC form till now.
Which term is this for your?
This is my last term for foundation.
No, like not last term, first, second term, or like third term.
Third,
Which term?
third term, sir.
First,
Third,
direct
third.
diploma. Third.
Sorry, this is my
Third.
third term.
Okay, third term. Okay, third term. Maybe you might get. No, basically, it was sent to all who have like completed their 2 terms. I don't know like what's the reason you didn't get. You might have got it for like 2 terms, but you might get it now. Okay. Yeah. Usually it's sent to all who have completed 2 terms, like who are active from the last 2 terms. Usually it was sent to all.
So actually, there was a mailing list like all student. I was not added to that till past 2 weeks. I mailed them. After that, they just add me there. I think that's why I am not receiving those kind of mail. This may be the reason. I don't know.
Yeah, it might happen. It's the technical issue from the support team.
Yeah, yeah.
So it might happen. So you will get when the TSC form will start from this term. It usually start after the anthem. Then you,
For the Jan term.
yeah, for the Jan term. Okay. After this anthem, they might release.
Okay, sir. Okay.